Okay, today we're going to look at adding fractions. So I'm going to give a very simple example of, let's say, 1 over 6 plus 4 over 6. Now I can represent this using a chocolate bar, which is partitioned into 6 pieces. So now let's say this is the first time you are eating this chocolate bar, not quite sure. Try the first one block. So that is represented using this part, 1 over 6. Now, hey, it's quite nice. It's got nice minty flavor. You like it. So you eat 4 more. You need to leave 1 for your brother. Otherwise, there will be a problem. So you eat 4 more. So that is represented using these blue shaded parts. So in all, how many did you eat? You ate 1, 2, 3, 4, 5. 5 out of 6. So you see that we do not add the denominators at any stage. So the first rule being, do not add denominators. And the rule applies the same for subtraction also. You cannot subtract. And the reason is, again, it is quite visible. You ate 5 over 6, right? So now we began with 6 out of 6 pieces. So 1 whole is 6. And you ate 5 out of 6. You are left with 1 over 6. So again, you are not subtracting. Otherwise, you would have left with 1 out of 0. That's not true. From the whole, which is cut into 6 parts, there is 1 left over. So if I were to show this, it is this one. You, out of the whole, you ate 5 parts, which is the red plus the blue, and you're left with the 1 part. Again, you're not subtracting the denominators. Okay, so that was the first basic rule. Now we are just going to focus on addition, and you can pretty much do subtraction the same way. I'm going to work with 2 fractions which have 2 different denominators. That's the second rule. You can only work with same denominator. So you have to have common denominator. Okay, so let's begin with a simple fraction. Let's say 1 over 2 1 over 2 plus 3 over 12. Alright, 1 over 2 plus 3 over 12. So, 5 over 12. Now, both of these are different denominators. I need to find what is the common denominator for these two. I need to have them both the same. Now, if you remember your equivalent fractions, you know that 2 can be scaled up to 12. So, how can I do that? 1 over 2 can be written as something over 12. 2 times what is 12? 6. 2 times 6 gives me 12. So whatever I do to the denominator, I have to do to the numerator. So I multiply the numerator also by 6, and I get 6 over 12 here. So now I've got 1/2 written as 6 over 12, which is true. Alright? So 6 over 12. Now I can work with my initial problem like this. 6 over 12 plus 5 over 12 equals 11 over 12. So the way I have done is I have written the equivalent fraction for one of these fractions because I can do it, right? If on the other hand, if I could not do, which is what we are going to look at in the next few minutes.